let's talk about absolute value function, how to graph absolute value function and what transformation we see for absolute value function. So absolute value function. So absolute value function is defined as f of x equals to absolute value of x. So you use two vertical lines and you put your x inside these two vertical lines, and the definition, as you remember, is the distance. It has a physical definition. The distance from x to 0. That's how we define absolute value function. Well, when it comes to absolute value function, mathematically, we say that absolute value of x is a piecewise defined function. It has two pieces. One piece is when x is larger than or equals to 0. The other piece is on the left-hand side of the domain, x is less than 0. So if x is larger than or equals to 0, the distance from x to 0 is just x. But if x is less than 0, since the distance is positive, you have to put a negative sign in front of your x. Okay, so how do I graph this? Take a look at the graph. Again, remember that we divide up this function into two pieces. This is the first piece. When x is larger than equals to 0, your y is x. Okay, let's graph this. So when x is larger than equals to 0, my y is x. However, when your x is negative, less than 0, your y is minus x. When x is less than 0, my y is minus x. Okay, take a look at this. So to graph this, we have our x-axis, we have our y-axis. So let us begin by the red part when x is larger than equals to 0. So when x is larger than equals to 0, it means that I'm working on this part of the domain. Am I right? And on this part, my x is larger than equals to 0. Then what is my y value? My y is exactly x. Okay, this is just a line, all right? Y is equal to x. X is 1, y is 1. X is 2, y is 2. So just connect these dots and you have your graph. Y equals to x. Well, this function has second piece, which is on the left-hand side of x-axis. When x is negative, it means that I'm here, all right? X is negative. I'm here on the left-hand side of x-axis. What is my y value? My y value is minus x. You have a decreasing line. It means that, well, if I take x to be -1, negative times negative gives me +1. If x is -2, negative times negative, +2. So I get a V-shaped graph. Y equals to minus x. V-shaped graph, absolute value. When you have absolute value of x, you define the function to be a piecewise defined function. Absolute value function is an example of a piecewise defined function. It has two pieces. That's why we call it a piecewise defined function. Let's take a look at our desmos. So here we have absolute value function. Okay, very good, that's cool. Let me make some adjustments to the absolute value function, see what the behavior is. I'm going to put a negative sign in front of my absolute value function, and this is what I have. As you expect, you see a reflection with respect to x-axis because you are changing your y value to be negative. Remember that your y value is absolute value function. Here you are defining a negative y equals to negative absolute value of x. As you can see, you have reflection with respect to x-axis. Now I expect you to ask, hey, what if I multiply my x by a negative sign? Ooh, there is no change in my absolute value function. Why is that? Because absolute value of x is equal to absolute value of minus x. So you have the same graph with the same definition. So that's why you don't see any changes to the graph, and it's already symmetric with respect to the y-axis. So let me make some more adjustments. Let me multiply my x by 2. Ooh, see what happens. It's multiplied by 3, multiplied by 4, by 5. I'm changing my x value, right? 6, multiplied by 10. As you can see, your graph is getting thinner and thinner when I multiply that by whole numbers. So if I multiply by 12, if I multiply by 17, multiplied by any number that you like, my graph starts getting smaller and smaller, thinner and thinner. It's the correct terminology. Now, if I multiply this by some fractions, like a half, 1 divided by 2 multiplied by x. Ooh, see what happens. A half times x, I get a wider graph. So if I multiply my x by fractions, I get a wider graph. The fractions are in between 0 and 1. If I multiply, for example, by 2/3. If I multiply by 2/7, 2/9, to 111, you see, it's almost like a flat line, all right? So if we just continue this, you get a wider graph. So these are the changes that you see. You can use desmos, multiply your function by different values, by different numbers, or you can make some changes to the y value. Hey, I'm changing my y value by adding 4, adding 3, adding 2, subtracting 1, subtracting 3, subtracting 6. So these are the changes that we see in the graph of absolute value. They're exactly following what we learned before, multiplying our x by some values, some numbers, multiplying our y by some values, by some numbers, and also adding and subtracting our x. X plus 3, shift to the left, x minus 3, shift to the right, x plus 5, shift to the left, x minus 5, shift to the right. So all of these transformations that we learned in this class apply to any function. It doesn't matter if it's a piecewise defined function or just a parent regular function.